So hi everybody and welcome back to C++ tutorials for absolute beginners. This is video 301, and in this video we continue with our value categories, and we stopped here with this diagram. We already talked about L values, PR values, and now we want to talk about X values. But before we jump into, we go back to the history, and the reason for that is we asked the question why we need at all X values, because here in C++98 there was no such kind of X values. It comes later with C++11. So the question is, when it works already with L values and PR values, why the hell we are making all things more complicated and introducing here X values? And the short answer is, actually there is not one answer, but there are many other issues as well, but the short answer is performance. What I mean with performance. So let's think again what happens here in C++98. In C++98 we had, let's say we had only L values, PR values, and then they used all time the so-called copy constructor, which we have already talked about. And the copy constructor is doing what? It copies all the values from one side to the other side. So it's creating new values. And this copy constructor is actually very expensive. When you have, let's say, 1 million data, and you just need for a short time this 1 million data, and you create then 1 million and then you use the copy constructor, and it is copying this 1 million data to the other place just to get the information about it for a short time. This is expensive. So in general, copy constructor is expensive, and they thought, do we have to use all this copy constructor all the time? Is this necessary? Because it is expensive. And then here in C++98 they used it all time, but in C++11 they introduced this new thing, this move semantics. This is the new word, this move semantics. And this move semantics actually means, yes, introducing also this new category X value, but we already could move PR values. That was already movable. We can move this one, but the question is now, what is this X value? Because we had already movable value categories, the PR value. And the difference is here now, this X value, when we watch again the properties, because again here a fast reminder, when we talk about value categories, you start here with an expression. Expression has a type and a value category, and the value category itself, like you can see here in the history, is defined with this two, with the two major properties, identity and can be moved, and they are using this here in the diagram as well. So if you want to distinguish this value categories, it's a very good start point when you start with these properties, and you can see X value has now the property can be moved. Also this one here, I can move it, and has the property has identity. And this has identity makes a problem, because we talked about the identity a little bit here in the category L values. This identity, of course, has different meanings, but one easy meaning is, just think about it, it's a storage location. It's not, if you go deep, it's not absolute accurate. There are some exceptions and so on, but it's an easy way of thinking and it works. But when we go now to X values, this is, yeah, it makes problems, because we talked in L values that we should never move storage location, so a variable which is associated to a storage location. And the reason was all time because it could be referenced in many ways before in other places which you not aware at the point when you want to change it to an X value, for example. And that's why they said, if it's an L value, just don't move it. So in theory, in practical use, you should not move an L value. Sorry, when it's an L value, then you should not move it. Theoretically, you can move it, but it's not, like I said, it's not practical. And now here, with the introduction of C++11 and the move semantics, because we want more performance, we want also move L values. So this one we want move anyhow possible. And it's still hard, it's still difficult, but there are conditions. They say it, there are some conditions, if we met them, we can make L values movable. And again, why we want to do this? Performance. Like I said, this example before, when you have 1 million data, L value with 1 million data, you don't want to use the copy constructor. You want to try to avoid it, and this is introduced now with C++11, the move constructor and the move assignment operator. And with this one here, we come back to the topic why we started here all the things with the value categories. What was it? Because normally we started here in class, we was here in classes. Then I talked about the constructor, the copy constructor, copy assignment, and I want to talk about this move constructor, move assignment. But then I said, wait a minute, to understand this one, we have to talk about the value categories. And now we are here in the value categories. We talk now a little bit about the value categories here. And now you understand that the X value, for example, is using this, this mechanism of this move constructor. And important to understand here is it will not use the copy construct. That's the big difference here. So you and this both here, instead of using the copy constructor, when you use the move constructor, you have a performance boost. So with other words, when we compare again C++98 and C++11, and let's assume you write a same project in both versions here, and this version should be faster if it can make a lot of use of this move semantics here, because like I said, it is performance boost, so our internal optimization. That's why they make it here more complicated, because normally you can everything achieve just with L values and PR values too. The difference is then you would use copy constructor, this one here, more because move constructor is not there. And copy constructor means then performance loss. That's why. And if you understand this one, then you understand now why it is so important to understand now as well this X value here. And X value is special because most time, not most time, but many times they convert L values to X values, which means they make it, they prepare it to use it with this move semantics here. So that means they make it, they say, okay, if it's an X value, I can use now this move constructor and move assignment, which is in a class, which you have to define in a class. And we will go there a little bit more in depth when we go to the examples. But overall, what you have to understand is that this X value is only for performance, and the use, and to increase the performance, they are introduced this move semantics. And the move semantics means this is the move constructor here, the move assignment operator here, which you put in classes, which you have as a programmer sometimes defined. It's not all time implicitly defined. There are conditions when it is and it's not, but if it's not, then you have to define them. So it can make use of that, and when it can make use of that, you get a experience boost. And examples for that we will show in the not in the next video, because we have still to talk a little bit here about other value categories still. But important is we will go through all these examples here. You can go through them already if you want, but you can see this is just a code snippet, and you have to convert the text here in all these examples to an actually code, real code example, and I will do this in a special video when we go through the whole value categories with a practical example. Right now we try just to understand it. All right, that's it for this video, and if you have any questions like all time, write in this comment section. And one note again, this is just an overview that you understand, that you get an introduction, because it's much more complicated later when you try to distinguish the exceptions. There are some exceptions in converting, implicit conversions, and all this kind of stuff. But again, we are beginners. We try to understand this. We try to understand later these examples here a little bit, and that's good. Of course, you should go and read a good C++ book if you want to go really dive into this one and understand it in a full way. But if we understand all these little examples here later and get the idea, that's enough for us. Okay, with that said, see you in the next video. Bye, good luck, have fun, and like all time, never give up.